Good morning, everyone. Myself Devika, working as assistant professor in the Department of Electrical and Electronics Engineering at Sri Muthukumaran Institute of Technology. Today, we have discussed the subject on W25C04 Basic Electrical and Electronics Engineering for 2025 regulations. In this presentation, we are going to discuss the topic PN junction diode. It is one of the most fundamental semiconductor devices used in electronic circuits. Contents. So, this presentation covers the definition, formation, operating principles, biasing conditions, current flow mechanism, applications, and conclusion of the PN junction diode. Definition. A PN junction is formed when P-type and N-type semiconductor materials are joined together. So this junction controls the flow of electric current and forms the basis of many semiconductor devices. Then introduction. So the P-type region contains holes as majority charge carriers, while the N-type region contains electrons. So the junction is created through a process called doping, which modifies the electrical properties of the semiconductor. Then formation of a PN junction diode. So when P-type and N-type materials are joined, so the electrons and holes moves across the junction. This movement creates a depletion region and an electric field that opposes further carrier movement, establishing the PN junction. So diffusion and drift mechanism. So due to the concentration difference, the electrons diffuses from N side to the P side and holes move in the opposite direction. This creates diffusion current and an internal electric field leading to drift current. Then operating states of PN junction. So the diode can operate in three conditions. One is no bias, forward bias, reverse bias. So no bias means the diode is not connected to any external source voltage. So no voltage is applied across the junction. In forward bias condition, the positive side of the voltage supply is connected to the P-type semiconductor, while the negative side is attached to the N-type, allowing current to flow. In reverse bias condition, the voltage supply is negative terminal connects to the P region and the positive terminal connects to the N region. So it preventing current flow across the junction. Behavior of PN junction diode under forward bias. So in forward bias, the P side is connected to the positive terminal and the N side is connected to the negative terminal. So the depletion region becomes thinner, so it reducing the barrier potential and it allows the allowing current to flow easily. This is the forward bias diagrams. Then reverse bias conditions. So in reverse bias, the P side is connected to the negative terminal and the N side is connected to the positive terminal. So the depletion region is wide, so it preventing current flow except for a very small leakage current due to the minority carriers. This is the diagram of reverse bias. Then application of PN junction diode. So PN junction diodes are widely used as rectifiers in power supplies, light emitting diodes, photodiodes for light sensing, solar cells for energy conversion, varactor diodes in tuning circuits. Conclusion. So the PN junction diode is a basic semiconductor device that controls current flow. It conducts under forward bias and blocks current under reverse bias, making it essential for modern electronic and electrical applications. These references include standard books on digital electronics and semiconductor devices used for preparing this presentation. Thank you.